Good evening everyone. Today I am going to discuss speed control of PMDC motor using DSPF28379D, and the ratings of the motor is 48 volts, 1800 RPM, 250 watts, 5 amperes. So now by using buck converter we are going to control the speed of the DC motor. So we already know this is the buck converter. So that means the step down converter. That means if the input voltage is high, output voltage is less. By varying the duty cycle, so we are going to control the speed of the motor now. Now by using model based development, so how we are going to control the speed of the motor using DSPF28379D. For that, first I have developed the logic. So here if you observe the logic, so the concept is the increasing duty cycle and decreasing duty cycle. So firstly, if you want to increase the speed of the motor, we have to switch on this increasing duty cycle by using some constant. And once it reaches to the 80% duty cycle, because I have kept 0.8 is the maximum duty cycle to protect my motor. So once it reaches the 0.8 duty cycle, so I will switch over to 1 here, then decreasing duty cycle will comes. Now the speed of the motor is going to be reduces. I mean, in this way we can switch over from increasing duty cycle as well as decreasing duty cycle. That means we can increase the speed of the motor as well as we can decrease the speed of the motor. So the very important thing we have to remember while we are working with motor control is we should not give duty cycle like 0.7, 0.8, 0.9 directly, because there is some inrush currents will be there, because starting back EMF is 0, so that's why there is a inrush currents will be obtained. So slowly you have to vary the duty cycle. So for that purpose we are using here increasing duty cycle and decreasing duty cycle. In the increasing duty cycle, what happens is we have used some counter concept to increase the duty cycle from 0.1 to 0.8. And coming to the decreasing duty cycle, again I have to reach from 0.8 to some 0.1 kind of thing. So that means the 0.1 required duty cycle I kept here. This is a down counter. So just here up counter and down counter I have used to increase the duty cycle from 0 to 0.8 as well as 0.8 to 0.1. So that is a very important point we have to remember while we are working with the motor. If it is a resistive load, directly you can give the 0.8 duty cycle, no issues. But whereas coming to this dynamic loads, so it is better to give duty cycle from 0.1 to 0.8, again 0.8 to 0.1, like that, to overcome the inrush currents. Now already I have switched on this monitor and tune, which is nothing but a PIL testing. So once it's done, here you can observe the code generation is in progress. So now if you come over here, so I am using this tachometer here, and so now I have kept 48 volt, 45 volts, 45 point something volts I kept over here. So now the code generation is almost completed. So now you can observe how the speed of the motor is going to be varied. Yeah. Now you can see slowly the duty cycle is increasing and the speed of the motor is also increasing over here. So now still 60%, 65%, the speed is 1300, 1400. Now finally the speed of the machine is 1434 RPM. So this is the voltage. So actually we kept 45.2 and now we are getting 36.7. Now the concept is, now the duty cycle is already reached to 80%. Now what is my aim is, I want to reduce my speed to from 1400 some change to 0 RPM. So now what I will do is simply I will change this constant value and the speed of the motor is going to be reduces. So now you can observe, so 1, and so now slowly the speed of the machine is reduces. You can see the duty cycle is reducing, the voltage is reducing, and the speed of the machine is also reducing. So in this way you can control your speed of the PMDC motor by using buck converter. Now at last we have a 10% duty cycle, and because of 45.3 volts and a small voltage 3 volts is coming here, so slowly the motor is rotating here. So this is about your speed control of PMDC motor using DSPF28379D. Thank you.